Hello everybody, it's Amell, and today I'm going to teach you how to solve the merge to sorted list problem. Merge to sorted linked list and return it as a new list. The new list should be made by splicing together the nodes of the first two lists. Here the given example. We have L1 list 1 and L2 list 2. So the key here is that the two lists are sorted in ascending order. So how can we solve this problem? What we can do is that we can use the domino technique to simplify the code, and we can have a cur pointer. Initially cur points to dummy, but then we compare the corresponding values in the list number 1 with the corresponding value in the list number 2, and we have a pointer L1 and a pointer L2, and we check which one is less. If they are the same, we can pick arbitrarily, but we choose the smaller one, and then we connect to the smaller one and move the pointer forward for the smaller one, and then we compare the 2 and the 1. I see the 1 is smaller, so connect it to the list and move the pointer forward, so now it's in 3. L2 is pointing at 3 and L1 is pointing at 2. I compare L2 and the value of the value of L1 and the value of L2. I see that this value is smaller, so I connect it and move L1 forward. So now L1 is pointing here and L2 is pointing here. Compare 4 and 3. 3 is smaller, connect it to the final result and move L2 to 4. And now I see that they are the same. I can pick arbitrarily, so I will pick this one. I'm done with this one. And at the end, I will connect this one. So this is the final result. So without further ado, I'm going to show you how to write the code. First, I'm going to have a pointer to node, dummy, gets the value of new list node with value -1, and cur points to what dummy is pointing to. Then I will say while L1 is not equal to null and L2 is not equal to null. That means that while I have nodes in L1 and while I have nodes in L2, I will do this. So I will say if L1.value is less than L2.value, I choose the smaller value, else. Okay, so for instance here, if I compare these 2 and with 3, I see that 2 is smaller, so I will connect the 2 to the final result. I will say cur.next points to what L1 is pointing to, and then I will move L1 forward. So L1 gets the value of L1.next. I will do the same for L2. Let's say if I'm comparing 2 and 3, actually if I'm comparing 4 and 3, and I notice that 3 is smaller, I connect 3 to the final result, and then I move L2 pointer to move forward. I move it forward. So cur.next points to what L2 is pointing to. L2 gets a value of L2.next. And after that, I move cur forward. Cur gets a value of cur.next. I have to move cur forward every iteration because cur is the pointer in the final result list. As I'm building the list, cur is pointing to the last node in the result as I'm building it up. So that's why I have to move it forward every iteration. Then there's a special case I have to handle. Maybe one list was longer than the other. So in that case, I have to connect the remaining nodes in the longer list to my final result. So I will say cur.next to make the connection. I will check which one was longer. If L1 is not equal to null, that means that L1 is pointing to something. So I have more nodes in L1 to connect. So if that's true, I will connect to L1. Otherwise, I will connect to L2. And I will say return dummy.next. Remember that the dummy node, the purpose was to store the head of the final result, so I can return it at the end. I will run the code, Alright, I will submit my solution. This is working perfectly. So the time complexity is big O of A plus B, where A is the length of L1 and B is the length of L2. The space complexity is big O of 1. In the next video, I'll teach you how to solve this problem recursively. If you like this video, please press the like button. Don't forget to subscribe, and see you next time!